In this example, we're given an integral, and we're told that the integral represents the volume of some region. We'll call it some solid three-dimensional region, which we'll call E. And we're asked to describe the region itself. And if we look at this integral, we notice that there's no integrand, so it must be 1. And of course, this product, dx, dz, dy, this is just a version of dv, the volume element. And so this is, it's definitely going to be the volume of whatever the region E is. And the region E is described by the boundaries of these integrals over here on the left-hand side of the iterated integrals. So what I'd like to do is write down these boundaries and then try to figure out what the region is that's bounded between all of these. The first one we see is that it's bounded, so the x, the inner, you have to work from inside out here. So the inner integral is saying that x is varying from 0, x equals 0 is the yz plane, up to the curve x equals 4 minus y squared. And that's a cylinder because there's no z's there. That's a cylinder in space. If we work our way out, and then we'll try to put these all together, but the next limit here is in terms of z, and we're told that because, again, we're working from inside out. The next differential is dz here. And so this limit, this integral tells us that z varies from 0 to 2 minus y. And then finally, the last integral here, this one is in terms of y, and this tells us that at the very end, y varies from 0 to 2. Okay, and so let's try to sketch these things. I'll give myself some x, y, z axes, three-dimensional axes here. And we'll try to sketch all these. So x equals 0, that's the yz plane. That's the plane of the screen that we're looking at. And x-axis is coming out of the screen, remember. But x equals 4 minus y squared, that's a parabola. So x equals 4 minus y squared is a parabola that is going to open in the y direction. It's going to, when y is 0, x is going to be 4. So it's going to pass through this point here where x is 4. And then it opens toward the negative x-axis. And so it looks like a parabola. It's not a very good parabola, but we're just trying to get a sketch here of what the region is going to look like. And this parabola is just on the xy plane. Okay? But if we add in the third dimension, there's no restrictions on z here, right? So what we end up with is that this is actually a cylinder or a sheet, cylindrical sheet, that has the shape of a parabola. Okay, so what we know now is that our region is bounded between the screen and this enclosed portion of the parabola here, the parabolic cylinder, and so it's somewhere in this region. Now we go to the next set of conditions, and that's here. So z equals 0, that's the xy plane, and the next condition is that z equals 2 minus y, that's a plane itself. That's a plane which when y is 0, z is 2. Okay, and the slope is negative 1. So that means that it crosses the z-axis, or the y-axis, sorry. So z will be 0 when y is equal to 2. Okay, and if we go back to this one, when y is equal to 2, that's the point of intersection here. Okay, and so this is going to end up being a line in the yz plane. But again, this stretches out. If we try to consider this in 3 dimensions, there's no restrictions on x, so that's a plane. That's a plane that's coming straight out of the screen here. It's impossible to draw it that way, but it's parallel to the x-axis, and it's coming straight out of the screen at this point. And so that's going to it's going to hit our parabolic cylinder up here, and it's going to cut it in such a way that we can now start to see what our shape is going to look like. It's going to look like a parabolic cylinder that's been sliced by this plane, okay, and sits directly above this portion down here of the plane. So that's enough, by the way. Actually, I've drawn too much, because actually there's another restriction that we haven't thought of yet. And that is that y varies from just 0 to 2. So y going from 0 to 2 means that actually this entire picture is cut off right here. And so it should meet there. And then what we end up with is just this portion that I'm really sketching in green. I'll pull this out and sketch it again myself separately. But this is the idea. So it's the region enclosed by this. So this is our region E. It's bounded between the X, Y, and Z axes, it turns out. Okay, it goes out to this point 4 in this direction, so this edge is part of it. It goes up to Z equals 2 in this direction, and then it goes over, downward, toward Y equals 2 in this direction. Okay, and so then how's everything filled out here? Well, this plane is extended here. All right, this is attached by a piece of a parabola, parabolic section here, and then the intersection of the plane with the parabolic cylinder, is going to give us some curve like this, and so we can start to shade in. And so that's what our solid E looks like right there. So this is our solid E.